So this video is on the classwork from the other day, classwork chapter 8, classwork 1, 8.11, I do, you do. So we had done a couple of these. I'm gonna do all the I do's for you guys and leave all the you do's. And again, we have done a couple of the you do's in class, but I wanna definitely explain the ones beyond number 4, okay? So when we're doing problem like this in the factored form, what we want to do is we first want to figure out what degree it is. So to figure out the degree, we're looking at all of these exponents here. So I'm going to be looking at this. Let me get the highlighter here. I'm going to be looking at this 2, this 3, and then here, there's really a 1 here. So for the degree, I'm going to add those up. And so this degree is going to be 2 plus 3 plus 1, which is 6. Okay, so this is going to be degree 6. And this degree 6 is actually going to be a positive because there's not a negative in here. So when I know it's a positive even degree, I'm thinking about it like it's a parabola, okay, which opens up. It starts and stops. We're talking about the end behavior here. It's not going to look like a parabola, but this top, it's going to start at the top and end at the top. Start above the x-axis, end above the x-axis. That's what all positive even degrees will look like, okay? So now the next thing I'm going to do is talk about the roots. So my roots are my zeros. These are my x-intercepts. So my roots is basically what makes each factor 0. So this is 0. And I'm going to put D for double. I have it twice. -5 will make that 0. I'm going to put T for triple. I have it 3 times. And then I have my 4. That's a single. Okay, so I'm just going to write nothing there. So all of my doubles should look like a parabola. By that root, it's going to bounce back whatever direction it's coming from. All of my triples should look like that S, like a x cubed type graph. And then all my singles will be linear and just go through. So let me just draw my graph. And when we draw the graph, we're concerned with the X, not with the Y for these. We're sketching, so the Y I'm not going to scale at all. So let's say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And let me put my points on here. So I have at 0, okay, and that's a double, so I want to pay attention to that. And at -5 and at 4. Okay, so again, I want to pay attention to, and I'm just going to kind of highlight them. Sometimes I'll do that for myself. Okay, so this right here is a triple, and this one here is a double. So we just have to be cautious of that as we come up to it. Okay, so now let me draw my graph. Okay, I'm going to change the faintness of it so I still see my points. Okay, so like a parabola, it's going to start above because it's a positive even degree. So it's going to start above. Let me make it a little less fat. Okay, so it's going to start above. And again, this was a triple. So what it should do is it's going to be coming down. And the way I kind of think about an x cubed graph in terms of graphing it is it's almost like half of an open up parabola and half of an open down, depending on where it's coming from. So let me make this a little darker. That's a little faint. Okay, so it's coming from here. So I'm going to do it like it's like almost like it's an open up parabola. And then once it hits here, the concavity, we say, changes. And now it's going to be like it's an open down parabola. Okay. And then it's going to come, and I don't care how low down it goes, it's going to come and it's going to go through this one. Now this is a double, so a double needs to bounce back like a parabola from whatever direction it's coming from. And then this is a single, it's going to go through. And that's your graph. Okay, so your number 2 will be very similar. So if you want to pause and do 2 if you didn't do it during class. I'm going to now do number 3. Okay, so on number 3, okay, again, I want to look at the degree here. So if I'm looking at the degree, this 3 is a factor, but it's a number. There's no x here. So any number is degree 0. Okay, so I'm not going to count that. This is a degree 2. This is a degree 2. So for my degree is going to be 2 plus 2 or 4. And again, it's positive. So again, I'm going to be thinking of it as like a positive parabola. Okay. So now let's look at our roots. And so my roots are my zeros. Again, that 3 is a 3. That's not going to be a 0. You can't make the 3 into a 0. It's a 3. I'm concerned about what makes this 0. So this is 3 times something times something. So the 3 is not going to get me the 0. This is going to get me 0. This is going to get me 0. So what gets 0 here is a 4. And that I'm going to put D because that's a double. And here, this is going to be a -2. And again, I'm going to put D for double. And then we're going to graph this. And so I've got 1, 2, 3, 4, 1, 2, 3, 4. Okay. And I am going to be plotting at 4 and at -2. And in these cases, both of these happen to be kind of special. Okay. Both of these are going to be doubles. So we got to kind of pay attention to that. Okay. Now, like I said, since it's an even degree, since it's an even degree and it's a positive, how do I know? It's a positive 3. There's no negative out here. Then it should start above the x-axis and end above the x-axis. So let me just make this a little less fat and get it a little lighter. So it's going to come here. And again, this is a double, so it's going to bounce back. Okay. And then it's going to come here. And again, this is a double. It's going to bounce back. And you notice that it's starting and stopping the same direction, which all evens do. And because it's positive, it's going to be like a parabola above. So if you want to pause it and try number 4, and then you can restart it, and we're going to talk about 5. So on number 5, this one looks different. Looking at it, if you're just looking at it, you can tell the degree when it's in this form by looking at the biggest exponent. So the biggest exponent happens here with the 3. This is going to be a degree 3. Okay, so this is going to be a degree 3. Now it is a positive degree 3 because my lead number in front is positive. And all of my odd degrees, I think of kind of like a line, a positive line. It should be starting below the x-axis and ending above the x-axis, going in opposite directions. Now, we don't know how to do it in this form. We want to factor this, okay? So this is where all the factoring from integrated 2 is coming back to haunt us, possibly. So you really need to make sure you understand how to, and some of those are going to be like the ones we did at the beginning of the year, okay, where they're a little bit more complicated. So when you see a problem like this, first thing I like to do is when I'm factoring, can I factor something out of every term? They're all even, so I can definitely factor out a 2. Each one of them has an x. The most x's I can take is x. So I'm going to have a 2x times 2, sorry, don't need the 2. I've already taken the 2 out. So 2x times, and here I'm going to be left with an x squared. Here, when I take 2x from this, I get a negative 2x. When I take 2x from this, I get a minus 15. And then I'm going to factor this. So this is just a diamond, a regular diamond, okay, because it's just an x squared. So really, I'm going to ask, hey, what multiplies to a negative 15 and adds to a negative 2? And that is going to be a negative 5 and a positive 3. And be careful of your signs. Some of us sometimes get a little lazy with our signs, and that's going to change your roots, your zeros. So this needs to be a negative 5 and a positive 3 to get a negative 2. And so my factors are going to be 2x times x minus 5 times x plus 3. Now again, if you double check, this is a power of 1, power of 1, power of 1. 1 plus 1 plus 1 gave me the 3, okay? So when it's in this form, standard form, it's look at the term that has the biggest power. That is the degree. Whatever the sign of that number is in front of it, that means that this is a positive verse, or maybe it's a negative. In this case, it's a positive, okay, positive degree 3. And now I'm going to find my roots. So my roots, now in this case, this 2x, that's going to be a 0. 0 is going to be what makes 2x into a 0. So anytime I have an x squared, an x cubed, with a number in front or without a number in front, it's always going to be a 0. And this is a single. And then my 5, single. And then my negative 3, single. So all these are singles. So I'm just going to go through, through, through. So I'm going to get my graph. Again, don't scale your y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just doing 5 because I have 5 as a number. Okay, and now I'm going to plot these. So I have at 0, I have at negative 3, and I have at 1, 2, 3, 4, 5. Okay, and now I'm going to draw my graph. And again, you need to pay attention to where we're starting. So this was a positive odd degree, so it's got like a line. It's going to start below and end above. Now each of these is singles, so I'm going to come and go through like a line. It's going to come back down and go through like a line. It's going to come back up and go through like a line. And it ends and starts in opposite directions. Again, it should start below and end above, and it does. So you can pause it and try number 6. Now I'm going to go on to number 7. So on number 7, similar to the last one where it's not in the factored form, this is kind of like the ones we were doing at the beginning of the year where we did the let u equal. You can do that. I'm not going to do that in my example, okay? And I'll show you why here in a sec, how I personally do these. But you can put a u here, and then that would be a u squared. You could let x squared equal u, and then this would be u squared, like we did in the beginning of the year, chapter 2, I believe. Okay, so I'm going to be looking at the degree first. So since this is in the standard form, I look at the biggest power. My biggest power is 4. So this is going to be a degree 4. And the coefficient is positive. So this is going to be like all even positives. All evens are like parabolas. Positive evens, positive, they're going to open up like a parabola. If this had been a negative, it would open down like an upside down parabola. Now I'm going to factor, okay? And so when I factor this, the way I think about this is one of those, I call it quadratic in nature, where if I look at this middle term here, if I look at this x squared, and if I square x squared, I get x to the 4th. So if you take the variable here with the power, ignore the 13. If you take this x squared and you can square it and get this, then it is quadratic in nature. So this is just a plain old diamond. Okay, and why a diamond? Because I don't have a coefficient in front. So what am I really looking for? What multiplies to 36 and adds to negative 13? So that's going to be a negative 9 and a negative 4. Now, normally this would be x minus 9, x minus 4. But this is not an x here like it normally is. It's an x squared. So when I do my factors, I'm going to do whatever my middle term is, x squared minus 9 and x squared, again, because of this, minus 4. So I'm just going to say this. If this had been an x to the 3rd, and this had been an x to the 6th, because if I square x to the 3rd, I get x to the 6th. I could have done the problem the same way. What would have been different is if this was an x to the 3rd, I would have had this be x to the 3rd minus 9 and x to the 3rd minus 4. Okay, as long as you can take this and square it and get this, you can just do this plain diamond if there's no number in front. Okay, but now these are special. These are the ones I kind of nag you guys about that you guys want to recognize. These are differences of 2 squares. difference of literally 2 squares. Okay, I'm subtracting 2 squares. That's what difference of 2 squares means. Anytime I have a difference of 2 squares, I'm going to take the square root of the front. Okay, so x, take the square root of the back, which is going to be a 3. One of them is going to be a positive, one of them is going to be a negative. That's why we don't have that middle x term, because I'm going to get a positive 3x when I do this math, and I'm going to get a negative 3x. They're going to cancel out. And then I'm going to do the same thing here. This is also a difference of 2 squares. This is going to be an x plus 2 and an x minus 2. Okay, and let's see if I can move this. See if I can move more of it just to here. Okay. So now I'm going to try to figure out the roots. Okay. So, and again, notice this is degree 1, 1, 1, 1. 1 plus 1 plus 1 plus 1 is 4. So you see how I get the same degree, but here again, I add the exponents. Here I look for the one that's the biggest. So I'm going to have a negative 3, which is a single, a 3, which is a single, a negative 2, again, single, and 2. So this is going to be just, everything's going to go through. And it should start above and end above, because it is a positive even power. 1, 2, 3, 1, 2, 3. Okay, so I am going to plot these. So I have a negative 3, I have a positive 3, I have a negative 2, I have a positive 2. Each of these is going to be single, so I'm going to go through. So I am going to start above, again, because it's a positive even, and I'm going to go through like a line, through like a line, through, through. Okay, so I'm going through, 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 through. Okay, so you can pause and try number 8. And hopefully that will help you with these. So again, you look at these ones to figure out how to do the you do problems. And this was your homework, was just finishing up the classwork.